So welcome to GM Ministry Davangere. I'm Anil Kumar TRV Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 10 to simulate the power angle curve of a generators in MATLAB. So these are the contents: aim of the experiment, theory, MATLAB code, plot for power angle curve and results. So aim of the experiment to write the program for power angle curve for synchronous machines using a MATLAB software. So theory, when we talk about the power angle curve of a synchronous machine, is a graphical representation of electrical output with respect to the power angle. As we know, the power angle is also known as a load angle. Therefore, it can be said that this is a graphical representation of electrical output of a generator with respect to the load angle. So procedure, we have to double click on the MATLAB software, and once it is open, then you have to go to the current folder. You will appear a current folders, command windows, editor. Everything will be open in one window. So now we have to open a new file to write a code for making the editing of your programs. Then type the MATLAB code and save that file in the name of .slx. Then the code should be run in the MATLAB. Once we run the programs, we are going to generate a power angle curve, will be plotted automatically. So this is the program for the power angle curve. That is P is equal to input. It should be written and power in megawatt, and PF is the input power. Vt is a line-to-line voltage. It should be in kilovolts. XT and XK value should be in the ohm, and Vt for phase voltage, that is, it should be converted into that is a phase voltage, line voltage divided by root 3 under the square root 3. It will be converted into phase voltages, and power factor is equal to A cos phi, and Q is equal to P into tan phi. This is for IQ, and I is equal to P minus J into Q divided by 10 megawatt divided by 3 into phase voltage. So delta is equal to 0 colon 1 and colon 180. You have tried semicolon at the end. So delta underscore radians, it is equal to, should be converted into radians. For that we are using formula delta into pi divided by 180. If xt is equal to xq, then the values will be generated, curve will be generated, and this is the program we are writing for the non-salient synchronous machines. You have to write the EF equations also, that is Vt plus J into I into Xt. For excitation, we are writing the EMF, that is ABS of EF. For regulation, this is the formula for writing the regulations. For net power is equal to 3 into power for non-salient divided 10 megawatt. So we have to plot plotting. We have to write the plot of delta comma net underscore power by closing the bracket semicolon. Then we have to write the end. Once we write the programs, we are getting a graph. Once we write the programs without making any errors, so we'll get a curve like this, and in the x-axis we have a delta. We can it will plot as per given your from the coding. Then in power angle, in the y-axis, that is in megawatt. This is the program we written for the non-salient pole synchronous machines, and this is a graph we can observe very carefully. And the result, when you come to the result, power angle curve is for the generator for synchronous machine, it is plotted. Thank you. So welcome to GM Ministry Davangere. I am Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the power angle curve for a non-salient synchronous machines. So for that we have to use a software called MATLAB. So in this MATLAB software we are going to write a program code for the power angle curve. So we have to go to the desktop, then see, you will find an icon called MATLAB R2023 B versions. You have to double click on the MATLAB software. So the windows will open. You should wait for a moment. So once the windows is open, so you have to see on the left top, that is we have home, plots and APPS. So go to home, there you will find a new. There have to click on the script to open a new editor window. So this is our untitled editor window. You have to save in the name called power angle. So I'll save in the name of power angle. So without giving any space. Then you can save it on the desktop. So once you save on the desktop, so you have to write the programs. So percentage of power angle curve. This is our legend. Then we have to give the inputs. So that is the power in terms of megawatt. We have to write P is equal to input, open the bracket and put the inverted commas, power in a megawatt is equal to, then inverted commas, close the bracket with semicolons. So like this we have to write all the lines. So PF is equal to input, that is a power factor. VT is a terminal voltage, that is line to line voltage in kilovolts. Then XT is the reactance that should be given as input in ohms, and XQ is the input, that is the XQ that should be in the ohm. So VT is this is the formula for the line to line voltage for a three phase, and power factor is equal to power factor underscore A is equal to A cos phi of power factor, then close the bracket with semicolon. So this is the Q is equal to P into tan power factor underscore A, then close the bracket with semicolon. Then this is the I, which is the current in the amperes, and delta. You have to write the delta is equal to 0 colon 1 colon 180 semicolon. So delta is equal should be counted radians is equal to delta into open the bracket pi divided by 180 into close the bracket with columns. So if xt is equal to xq, then we have to write the EF and excitations. So here we are using a legend to mention that it is a non-salient synchronous machines for measuring the power in the megawatt. So we are writing the x label because we require a delta in degree on the x-axis. In the y-axis we require the megawatt. That is why we should we should find the megawatt on the y-axis. That is y level is equal to power in the megawatt. And this is our title, that is a power angle curve for a non-salient synchronous machines. Right, and this is the net power. This is the power equations, and we have to give the plot. So once we give the plot, then only it will plot on the x-axis delta and y-axis on the power in the megawatt. So this is our actually programs. After writing the programs, you have to select the programs. So once you select the programs, go to the run sections. So once you run the section on the command windows, you'll get the input what we have to provide the input for the power in the megawatt. So here I will give the power as a 48 megawatt. Then enter. Then you have to give a enter. So it will ask for the power factor next. For power factor we are providing the 0.8. Again you have to give the enter. So line to line voltage. So line to line voltage it is 34.68 kilovolts. Then you have to give a enter. So what is our XT? That is reactance. It is same XT is equal to XQ. Here I already mentioned XT and is equal to XQ. So I will give the same values for XT and XQ. That is 10. So that is I will provide the here 10. Then I will give the enter. It will ask for XQ also. Again I will give the 10. Then I can see the waveforms it will be generated. And this is our actual the waveform which is generated. Right. So if you want to see once again, I will show you making the clearance. Then select this program. Right. I will repeat once again. Select this program. Go to the run sections. They'll ask for the power in the megawatt. You can give the power as a 48. Then put enter. Power factor is 0.8. Then enter. It will ask for the line to line voltage. That is 34.68. It should be in the kilovolts. Then it will ask for the XT and SQ. That is we are providing the 10. Again enter. Give 10. It will generate a graph. So you can see once it will generate a graph, we have to analyze. We have to analyze the power angle curve. That is on the x-axis it is delta, which is in degree, and y-axis it is power in the megawatt. Right. So this is actually our power angle curve for a non-salient pole synchronous machines. So you can see the waveforms. These are actually the waveforms for the, and we are given the legend also here. You can see there is a legend where it shows the this is the legend for the non-salient pole. In the graph also you can see here there is a legend for the non-salient pole. Same legend we have written. So it shows what is actually the type of the graph it is plotted. Right, in the x-axis it is delta in degree, and y-axis it is in the megawatt. So this is the plot for a power angle for non-salient pole synchronous machines. Thank you.